Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying binomial lecture 2. So let us talk about middle term if n is even and the second case would be if n is odd. So let's say we have this expansion x plus y raised power n and n is even over here. Okay. Now we know that in case of x plus y raised power n we have n plus 1 terms. So if n is even then we'll be having odd terms. So let's say n is 6. Let's say n is 6. So we'll be getting T1, T2, T3, T4, T5, T6 and T7 because we have n plus 1 terms for n power, right? Now we can clearly see that if n is even, the middle term would be this one. So basically we have 3 terms in the left and 3 terms in the right. So middle term would be T4 over here in this case. So that means n by 3, sorry, n by 2 plus 1. So this is the fourth term. So n by 2 plus 1 term would be our middle term in case of n is even, right? Now let us talk about the second case if n is odd. Let's say this is x plus y raised power n is odd. So basically n plus 1 would be even. So let's say n equals to 5 over here. Then we'll be having T1, T2, T3, T4, T5 and T6 as the terms because n is 5, so you should be having 6 terms. So we can see that either this should be the middle term, but there is nothing over here because we have 3 terms in the left side and 3 terms on the right side. So ideally there should be some term over here that should have been called as middle term, but we don't really have any kind of term over here. So we'll be taking these 2 terms as the middle term. So this one and this one too, both would be reported as the middle term. So how do we define it mathematically? N plus 1 by 2th term and n plus 3 by 2th term. So this is how we have to define the middle terms. Middle terms in case of n is odd. In case of n is even, we have defined by n by 2 plus 1th term. And over here we have defined by n plus 1 whole divided by 2th term and n plus 3 whole divided by 2th. And this is how we have defined middle terms in case of n is odd and n is even, right? Now let us talk about numerically greatest term slash coefficient. So the keyword over here is numerically greatest. So basically we have to find out the maximum absolute maximum value. It's not like we are just mentioning we are just considering the positive values and neglecting the negative values. We have to find out the numerically greatest, basically absolute values which are maximum, right? Now that was the first point. The second point is we know that whenever we write x plus y raised power n expansion, then the coefficient values they slightly increase, then they become a little constant, and then they decrease. So they might or might not become constant. Sometimes it's just one single value at the top. Sometimes there are two values at the top. Numerically greatest, not talking about with the sign. Numerically greatest values, they can be either 2 or 1. So this is how it is for the coefficients of binomial expansions. Okay. Now with the help of this, now we can start the derivation part. So basically, if at the top we have kind of a local maxima over here, just like we studied in the EOD, we have a kind of local maxima over here. So that means the immediate terms should be lesser than this term, right? So let's say this is TR plus 1. Then this term that would be TR plus 2, the immediate term, and the immediate term on the left that would be TR. So this is how it should look like. We know that we can have equality, but for only two numbers. We cannot have equality for more than two numbers, or we can have just one single value. So greater than equals to TR and greater than equals to TR plus 2 as well, right? So let's start the derivation part. So let's first derive TR plus 1 greater than equals to TR plus 2. And now we have to take the modulus as well because we are finding numerically greatest term. TR plus 1 can be negative, right? Or TR plus 2 can be negative. So we have to take the modulus as well. Now TR plus 1 would be NCR dot X raised power. Now we are defining for X plus Y raised power N. Now remember that this X can be AX and this Y can be BY. We'll do that later. But as of now, we are defining for x plus y raised power n. So this would be n minus r dot y raised power r modulus greater than equals to ncr plus 1 because we have r plus 2 over here dot x raised power n minus r minus 1 dot y raised power r plus 1 modulus. Now we can cancel out this and this entire term, and also we can cancel out this, sorry, this with this, right? So we'll be left with x by y modulus greater than equals to ncr plus 1 divided by ncr modulus, right? If I try to write this expression, you'll be getting n factorial divided by n minus r minus 1 factorial divided by r plus 1 factorial and multiplied by n factorial, just I'm taking this upwards, and multiplied by over here will be r factorial dot n minus r factorial. Now this n factorial gets cancelled out, and we know that we can write r factorial as r into, sorry, we can write r plus 1 factorial as r into r plus 1 factorial. So this is r plus 1 into r factorial. So this r factorial gets cancelled out. And similarly, this one can be written as n minus r multiplied by n minus r minus 1 factorial. So this n minus 1 and the n minus r minus 1 factorial and this n minus r minus 1 factorial gets cancelled out. So basically we are left with, this looks a little messy, but we are left with n minus r divided by r plus 1 modulus. So basically we have got the expression modulus of x by y greater than equals to modulus of n minus r plus 1. Now one thing to understand, when we defined NCR, we know that n is always greater than equals to r. So basically this term is always positive or maybe 0, right? And r is always whole number. So r plus 1 is always positive. So we can remove the modulus, right? So basically this becomes, we can write this as n minus r minus 1 and plus 1 divided by r plus 1. So this also can be written as n plus 1. Why I did that? Because I want to eliminate this r from the numerator. We have r in the denominator and we have to find out the condition in terms of r. We have to find out the value of r to find out the term number of the position of the term, right? So that is why we have to eliminate r from the numerator to get a single point in the denominator. So that would become n plus 1 divided by r plus 1 minus 1, right? So this would give me modulus of x by y plus 1 greater than equals to n plus 1 divided by r plus 1. Now if I take this, I just do the cross multiplication, I'll be getting r plus 1 is greater than equals to n plus 1 divided by modulus of x by y plus 1. Now what I'll do, I'll term this as m. So basically this would give me r plus 1 is greater than equals to m, r is greater than equals to m minus 1. So this is our condition for finding out the value of r. Now this was just one part of derivation. This was just t of r plus 1 is greater than equals to tr plus 2. We also have to find the second part. Now I'll just give the result because the derivation is too lengthy. So the result is basically r is greater than equals to m minus 1 and r is less than equals to m. So this is our final condition for finding out the numerically greatest term or coefficient. Now this we actually derive for x plus y raised to power n, and m over here is n plus 1 divided by modulus of x by y plus 1. This is our m value, right? Now you can see that we are actually dividing x by y over here. So x can be over here ax and y can be capital By. Now if we have to find out the numerically greatest coefficient, in that case what we'll have to do, we'll have to put x equals to 1 and y equals to 1, right? Why? Because as of now we are including x and y both. We are including both the terms, including the variables, to find out the numerically greatest term. But if we just have to find out the numerically greatest coefficient, we have to put the value of x and y as 1. So we have to use the same expression for finding out the greatest term and the coefficient, right? So you have to remember this condition and the value of m for finding out the results. Now let's look at one question. Find the term which has numerically greatest coefficient in the expansion of 3x minus 2 raised power 21. So basically we have to find out the numerically greatest coefficient. So eventually we'll have to put the value of x over here as 1. So let's try to find out the value of m first. M would be n plus 1 divided by modulus of x by y plus 1. So n over here is 21, that would become 22 divided by x by y, that is 3x, and y is minus 2, not 2 only, minus 2 plus 1. So over here we have to find out the numerically greatest coefficient. So that means x is nothing but 1, right? So 3 multiplied by 1. So this would become 22 divided by 3 by 2 plus 1. That would be 5 into 2 over here. So 44 by 5, basically 8.8. Now our condition was r is greater than equals to m minus 1 less than equals to m. So basically r is greater than equals to 7.8 and less than equals to 8.8. So basically r is 8 only, right? Now we have got the value of r. So we have to find out the numerically greatest term. For that we have to do tr plus 1 and we have to write the general term, right? That you can do. Now let us look at this example. The largest term in the expansion, we are talking about the term over here. The largest term in the expansion of 3 plus 2x raised power 50, where x equals to 1 by 5 is. So they have given the value of x over here because we have to consider the value of x over here to find out the largest term, not the coefficient, right? So again, we'll be calculating the m value. M value is n plus 1 divided by modulus of x by y plus 1. So that would give me 50 plus 1 divided by modulus of x by y, that would be 3 by 2 into 1 by 5, right, plus 1. So that would give me 15 by 2. So this would become 15 by 2. So this is 51 into 2 divided by 17, right? So this is 3. So this is 6. So now the condition would be r is greater than equals to 6 minus 1, that is 5, and less than equals to 6. So basically we have got two values of r over here. So 5 and 6. So if we have to find a term, then that would be tr plus 1. So basically t6 and t7. This would be the answer. So you can find out the value afterwards. Okay. So today's lecture was till here only, and we have studied the difficult most topic, that is the numerically greatest term and coefficient of the binomial chapter. And after that, it's quite a cakewalk in the entire binomial chapter. So let's meet tomorrow. Thanks for watching.